Right, hello guys. I just want to talk about certain questions from this exercise 3B. So the first question I want to I'm only going to talk about 3 questions to be honest, but the first one I want to talk about is number 6. Right. And it's quite straightforward and you ought to be able to work it out without much difficulty really. But I just do want to say one thing about it really. The distribution is normal with mean 4.5, and don't forget variance 0.4, not standard deviation, variance. So therefore, when we're trying to work out the probability that t is less than 4.2, then what we're putting into the calculator is we'll do this directly. There's no other work to do here. So on my calculator, I feel like you can see that okay. I'm already on that distribution, aren't I? So number 7, it's normal CD. Remember I said normal PD is hardly useful at all. So number 2, normal CD. Now it's less than 4.2, so we want to go for a really big negative number. So like minus loads of 9s. I didn't do as many as normal there. Up to 4.2, okay. And what's sigma? Sigma, it's not 0.4, is it? It's the square root of 0.4. And, they are, it's worked it out for us. And mu is 4.5. Okay. I'm going to press equals and it's just going to tell me the answer straight away. There we go. 0.31. 318. Now, is that what I would expect? Yes, it is. I'm just going to... I knocked everything here. I'm just going to draw a little picture of that normal distribution. The mean is 4.5. And it'll look like they always look the same. Okay, I want less than 4.2. So I want this area here. So am I surprised that it's 0.318? No, I'm not. It ought to be less than a half. So that there is 0.318. That's what I was anticipating. Now, this is what I want to talk about. On B, it says... what's the probability that t is greater than 4.2? Okay, that's 4.2 there. I'm just going to write that actually in black. 4.2. So probability t is greater than 4.2. I'm just going to do it straight away. 0.682. Okay, now, these two probabilities are complementary. What do I mean? They add up to 1. And you might be thinking, well, hang on. What about the probability that t equals 4.2? Well, that's what I'm on about. This is a normal distribution. It's a continuous distribution. Therefore, there is no probability that t equals 4.2. It wouldn't be allowed to equal 4.2. The probability t equals 4.2 is 0. So these are the only two things that can happen. Either t is less than 4.2 or t is greater than 4.2. There's nothing in the middle. Okay, right. That's number 6. Sounds. The next question I'm going to look at is number 9. Okay, and it says in number 9, it says it's called W, which is the amount of water in a bottle, and it's normal with mean 500. So like I was talking about, that means that's what's written on the label, and the variance is 14 squared. That's a nice handy way to write it. So just dead easy, the probability that W is greater than 505 is, I'm going to put that in my calculator. I keep knocking stuff. So, menu. I'll just always go to menu. Number 7, yeah, normal CD, please. It's greater than 505, so my lower value is 505. My upper is just some big number. Sigma is 14, nice one. And mu is 500. Okay, there we go. Yes, 0.306. Again, I'm just going to illustrate that. 0.306. An illustration never hurts. Just to clarify your thinking, there's 500, there's 505 there. So is that plausible that be 0.306? Yeah, it is. Okay, it's gone off the screen. But there we go. Right, so the second part of that question wants the probability that W is less than 490. Oh, my hand's really in the way here. Sorry about that. 490 is, and I'm going to do this on my calculator again. A little like, oh no, we are. There we go. We'll change it now. So less than 490. So my lower value is a big minus number. My upper value is 490. Same sigma and mu. And it's 0.2375. 0.2375. And once again, just a little diagram to illustrate. They're not very good, my diagrams, but they do the job. 490. Is that 0.2375? Well, it doesn't look like it from my scale there, but it'll do. So there we go. There's me answers right now. Look at this then. A sample of 4 bottles is taken. I want to know the probability that all 4 bottles contain more than 490 millilitres. So if I've got 4 bottles in a row, let me draw a picture to represent that. I've got 4 bottles in a row. There's one. These are rubbish, these. 2. 3. Oh my goodness. Yes, okay. So I want to know that all 4 have got more than 490 in them. So this one, probability that is 0.2375. This 0.2375. This one 0.2375. And that one 0.2375. So all of them, probability of all of them more than 490 is going to be 0.2375. That's a 0 that. 0.2375 to the power 4. These are all independent, so I'm just going to times them all together. So I'm going to do that on my calculator. I'll have to just go to the normal calculator function. 0.2375 to the power 4. There we go. Ooh, that's a really remote probability, that. No, I've done it wrong. Sorry, I'm not gonna redo it. Right, greater than 490. Well, do you know what? Read the question, Mr. Murphy, innit? So this is not 0.2375, 0.7625. They're all 0.7625. Sorry about that, guys. 7625, 0.7625. So the probability they're all greater than 490. That was literally the exact reason I picked this question. 0.7625 to the power 4. So this will be a nice, reasonable probability. 7625 to the power 4. There we go. 0.338. Okay. So that is saying, right, if you pick one of these, 4 of these bottles, the probability they all contain more than 490 is 0.338, which is about a third, isn't it? So that's it doesn't fill you with loads of confidence, that, does it? I'll come back to this in a sec once I've looked at question 10. So the last question I want to look at is question 10. Okay, so question 10 is, I'm going to say, let the height be h. Let height be h. Okay, then h is normal with parameter, with mean 165, and the standard deviation is 3.5. Okay, so our average woman is 165 centimeters tall, and did I say, didn't I, 2/3 of the population lie between then 161.5 and 168.5. That's sort of what that means. Right, what's the probability? H is less than 160. Let's do it on the calculator. So here we go. Normal CD. It's got an upper bound of 160. So a load of 9s there. I want it to be 160. My standard deviation is 3.5. And my mean is 165. Okay, there's my probability. So 0.0766. That's 3 significant figures there. Okay, for part B, so Stephen is looking for a woman whose height is between 168 and 174 for a part in his next film. So we want P, 168 is less than H, is less than 174. Now, I like them. I think they're the best. I don't mean women, the height. I mean, I like when it's between them, because you don't have to do no messing around with these big numbers or little numbers. So I'm going to put 168 in there and 174 in there. It's the same sigma in the same mu. So here we go. There we go. Equals. So 0.1906. That's what we've got. Okay, right. Now, let's look at C. So for part C, he takes a sample of 20 women from the group. This is a large group. So find the probability that at least 5 of the women meet Stevens' criteria. Now, I'm going to say this now. This is a binomial situation. Why? Because I've said loads, haven't I, what's the criteria for binomial, but all of these women are independent, so we can assume that. What else? They are all either, and this is important, they're all either they meet Stevens' criteria or they don't meet Stevens' criteria. So that's the thing about, you know, either it's sort of like true or false or yes or no. That sort of, there are two outcomes. And is there a fixed probability of success? Yeah, that's the fixed probability of success, 0.1906. And have we got a fixed number of trials? Yes, we've got a fixed number of trials of 20. So this, then, I'm going to say, let Y be the number of, I'm writing very strange here, of women meeting the criteria. Then I've got Y is binomial with parameters 20, because he's picked 20 women, and 0.1906. And then what do I want? I want the probability. It asks Y is, it says at least 5, greater than or equal to 5. So now I'm going to go to my calculator. I'm going to go to distribution, and this is binomial CD. Oh, actually, I'm not going to go to my calculator yet. I will in a sec. Variable. That is, just think back to the want Y to be greater than or equal to 5. Okay, so I'll put some of them in. Like 2, 3, 4, 5, 6, 7, 8. I want Y to be greater than or equal to 5. So I want all of them. That's 1 minus probability Y is less than or equal to 4. So if I work that out then, so X is 4, N is 20, P is 0.1906, and then equals, so that's 1 minus 0.6704, and that is 0.3296. Okay, now that's all I have to say. I just want to refer briefly to the previous question to say that this situation was also binomial. And I could have done this by not doing it directly. That's just a brute force way of doing it. I could have said it's binomial with parameters 4 and 0.7625. And if I'd have done that this time, it would be binomial PD. It'd be X is, this is just a, oh no, it's the previous one, yeah. So 4, I want it to be 4, N is 4, and P is 0.7625. And then there you go. I get the same probability there as what I actually got when I worked it out myself. So I could have considered this to be a binomial distribution as well, but it was obviously quicker to do it myself by hand. Right, that's all I have to say. Well done, guys. Nice one.